Welcome to Privacy Preserving Measurement. You've seen the note well. It's Thursday. I'm not going to read it to you. Next. Thanks. I don't see any nostrils in the room. I'd like to keep it that way. If you need to take a sip of water, put your mask back on afterwards. You know how to use Meet Echo. Make sure if you're using the full version here, you don't turn on your microphone because we'll get feedback in the room. And if you're speaking at the microphone, keep your mask on. I think we're ready for Siobhan. Siobhan's going to talk about STAR, and then we're going to move on to Dap.
Press Control slide. You need to give me access, or? Yeah, that's the. I can just say next slide.
Chris, are you in queue for agenda bashing?
Yes, I'm in queue to bash the agenda. There was no opportunity to do so. I would like to request that this be moved to the end of the session so we give appropriate amount of time for all of the DAP-related issues that we have. We need to make sure we get through those prior to discussing non-working group items at this time.
Thank you. The chairs have decided to do otherwise. Chris? Chris Patton?
You. I for one, I'm remote. I'm having trouble hearing the room. It's very choppy. Is anyone else having trouble hearing?
Oh, all right. Is it me
also
that you're having trouble with, or Siobhan, would you say a word at that mic?
Hello, hello, hello. Is that okay, Chris?
Okay, it's just me. Chris Wood, can you cover me if I am not able to communicate with people? I'll figure it out on my end. I'll be back, but yep.
Okay, go ahead, Siobhan.
Right.
And Chris Wood, I'll answer you offline.
Hey all, my name is Siobhan, and Alex, Pete, and I have been talking about STAR for a while. STAR was a research paper. It's going to come in the it's going to appear in the upcoming CCS, I think. And yeah, looking forward to discussing it with folks. The central idea is that we'd like to have K anonymity for clients reporting potentially sensitive measurements to an untrusted server. And the pretty important goal that we have is that it should be cheap, because Brave is a small organization, and there are other similar small organizations who would like to do privacy preserving measurement, but don't have an infinite AWS money to spend on that. And so yeah, so low computational overhead and network usage for clients and servers is pretty important. It should, I guess, similarly, it should also be easy to implement using well-known cryptographic techniques, and obviously should also be private. The central idea here, I won't go into too much detail. I think Alex's presentation at the last IETF did a good job, but essentially we're going to use Shamir's secret sharing. So you get a symmetric key through some deterministic function operation on the initial measurement, and then you encrypt the measurement using that key. And so the idea now is that you can only get X when you have K. So you generate a secret share of K. and you send the measurement and the secret share to the server, and the server gets a bunch of these, but it doesn't know what M is until it can perform the recovery operation on K, on the secret share of K, and it can only do that once there are N of those. So in this way, you get like K anonymity, where N is the number of minimum number of shares you need. And then you can use K once you recover it to decrypt M and get the original measurement back. And it's really important to have an anonymizing proxy here. So I'll talk a little bit about this later on, but essentially once the measurement is decrypted, you want to be sure that you still don't have access to the IP address of the people submitting this. And also you have to use a randomness server because you could also do this locally, but we decided that it's just a lot better for privacy reasons if you use this. So the idea is that the client sends a blinded input value to the randomness server and it gets a salt back. And if you have the same input value, then all of those clients would get the same salt back. And this is done to like mitigate the server brute forcing all possible input values, because if the space for if the initial measurement is not doesn't have enough entropy, then the server can very easily brute force all possible values and then just see what the values match up with the encrypted value. And then, yeah, we also use an OPRF to make sure that the randomness server does not learn the input value as well. This is the architecture. So there is a randomness phase, like I mentioned, where the client talks to the randomness server and gets back the random value that it needs to generate the message. And then there's a key rotation. And this is done so that when the aggregation server gets the message, the randomness server has already rotated its keys. So the aggregation server can't ask the randomness server at this point. And yes, and then the client sends the encrypted message over an anonymizing proxy to the aggregation server. And then there's an aggregation phase where you can reveal the original message if it's sent by enough clients. I'm fine.
You're
Right
fine?
now it's fine, yeah.
Yeah. We're all allowing only 10 minutes for this now, so take questions or not
Sure.
if you like.
Yeah. Okay, cool. So the implementation status is that we're shipping this in Brave for some telemetry. There is an open source Rust implementation with some WASM bindings. And we right now are using a TCP proxy for the anonymizing proxy bit, but we're experimenting with using an OHI one. Yeah, and we made a bunch of changes given the feedback that we got at the last IETF on mailing list and through conversations. So we don't use puncturable OPRFs anymore. And we just simply rotate the keys, like I mentioned. So the randomness server, the client can only sends the encrypted value to the aggregation server in the subsequent epoch after the randomness phase. And yeah, we also require the use of a randomness server just to make, I guess, keep things simple, and you don't have to like then make that decision yourself. Oh, do I need one? Do I not need one? And also apart from that, just a bunch of documentation of the risk of collusions between various entities, and just a lot more like details on leakages in the security consideration sections and stuff like that. And yeah, and we think it's ready for adoption. We spoke a bunch to Chris Wood, and he had some good comments, and I think we will be making those comments, but I think at this point it would be great if that's a working group. If the draft is like a working group thing that the working group works on, instead of just a couple of people. So yeah, we're happy to hear any comments about that.
Thanks, Sean.
So, first question, how long do you envision the epochs being?
Say that again, sorry?
How long do you envision the epochs being?
How long do we
Envision the epochs being?
The epochs being.
Because now that you have to rotate the keys every so often, right? And you say you can't upload the data until after the,
Right.
So how long do you envision the epochs being?
Right. So right now we use it. The time period we use is 1 day.
Okay.
But that's what we imagine would be.
Sure.
the one. Yeah.
Okay. My second question is, what happens if I, as a client, generate a bogus share? What I mean is I generate a share that corresponds to a different encryption key.
Yeah, so this is something that Chris would brought up as well. And so you mean like when you finally decrypt it, you get a value that is not the same as the other ones, right?
Well, that's not what happens, right? No. No, I generate a Shamir secret share that corresponds to a random value. So that when you reconstruct, so Shamir secret share, right? Any endpoints, right, allow you to reconstruct, right? And so imagine that amount like a modest Sybil attack, or 20%. So you need 500. So you need 500 shares, and 10% of the shares are bogus, and correspond to, and correspond. So what happens then?
So, but is a secret share, you're trying to attack a particular?
What I want is to make it impossible for you to reconstruct a given value. So for instance, like you're collecting the top URLs, right? And I want to make it impossible for you to collect the google.coms on the top URLs. So what I do is I generate a, I generate a thing that has the encrypted value for google.com, but has a secret share that corresponds to a random point.
I think generally we are keeping Sybil attacks out of scope, because I think that's a common problem with like many systems. But the one thing that we were talking about with Chris is that if on decryption, like that's one aspect of it, is that on decryption, if you see a value that is different from everyone else, then you.
No, I think you're misunderstanding me. No one will be able to decrypt.
Right. I see that. I think in general, like, we will be not considering Sybil values for.
Okay, but this is like the most trivial denial of service attack in the world. Like basically, like so. So let me try to get the point. If because of the way Shamir secret sharing works, if any input value is bogus, the output key is bogus, right? So if I can convince you to take as one of the quorum of n keys that you use to reconstruct a point of mine, and my point is bogus, the consequence will be the key is bogus, and now you can't decrypt any of the values because you correspond to a random key, and so the AED fails.
But you still wouldn't be able to. You would still be waiting for enough number of.
No. Because so as I understand it, you inventory. You sort the keys, you sort the inputs on the encrypted value, right?
Right.
Good. So you bucket them up on encrypted value, you take the corresponding secret shares, right? Now you reconstruct the key. And now you get a key and you try to decrypt them, and none of the values will decrypt. And so, because if you reconstruct one key, you've reconstructed a random key, right? So you've got to find some way to reject the bogus key, the bogus inputs, right? And so, if I remember correctly, there was some technique that Apple used in their in their system for this, but like I don't know how to do it with this design. So, I think this actually doesn't answer for this. I think it's not just. I mean, so Sybil. I mean, it's like one thing to be like we don't have grand Sybil attacks, but like the situation where the situation is that like if I can get any small fraction of the keys that you can't decrypt, that's like actually very serious. So I think you need a way to reject bad input shares.
Okay. Yeah, I got to think more about that. But did you have another?
I don't know how to fix it. I think, as I said, my pointer would be that there was a that in the Benet, I can't remember the Myers, Apple, CCM thing. They had a secret Shamir secret share scheme, and they had some way to reject bogus values. So maybe you can steal that, maybe you can't.
Okay. The queue is closed, and Alex, it's you're the last speaker.
Hi, can you hear me okay?
Yes, Alex.
Yep. Yeah, I'm Alex. I'm one of the authors of the Star Draft, co-authors of the Star Draft. So in answer to Eric's question, that's what we do in Brave is we take the minimum threshold number of shares and try to reconstruct. And then if we can't reconstruct, we keep taking random sets of shares. So that's like one thing that we do.
But that won't work if there's any substantial fraction of shares are bogus.
No, it won't.
10%. Say your threshold is 500 shares, right? And 1% of the shares are bogus. What is the chance that 99%? So 0.99 to the 500 is like an incredibly small number. So like it doesn't work. It doesn't work against that kind of attack with any kind of power at all.
Agreed. But the adept secret sharing framework that we currently have has like a mechanism for deciding whether shares are authenticated or not, and that's the thing that we use.
How do you authenticate it?
There's mechanisms in the adept secret sharing framework to decide whether shares are valid or not, and whether they agree with a certain policy.
Okay, I do have to write this down because like. Sorry.
I think the thanks for highlighting that point, I think we're out of time. We need to move to the next speaker, which is Tim. Thanks for mentioning the question of adoption. We might come back to that if there happens to be a time at the end of the session. Chris, I see Tim is in the queue too. Tim, this is your presentation. Do you want to present slides?
No, go ahead if you have them.
Oh, I see a slide request. I'm happy to approve that.
Here we go. Okay. Let's see. And I got buttons. All right, great. Let's get started. Okay. So in this particular deck, we're going to cover the current status of implementations of DAP. Then I want to talk about a small number of the notable changes in the most recent draft 01 of DAP. And then we're going to use that to segue into the discussion of a couple of one or two open problems that the chairs have encountered and that we're interested in discussing in the working group. Before I move on, I just want to check, can the room hear me? Everyone can hear me okay? Chairs?
We hear you clearly on site.
Sounds good. All right. So implementation status. So as of right now, we have 2 implementations of draft, IETF, PPM, DAP 01 that are up on GitHub. So first there's Daphne, which implements a DAP leader, helper, and a collector, and is written in pure Rust. Then Janus is another implementation of DAP server components, also written in pure Rust. So Daphne and Janus are independent implementations of DAP, though they do share some common dependencies, which we'll get to in a minute. And finally, there's DivvyUp TS, which is a client, so it only has enough of the protocol and cryptography bits just to do report uploads. And it's written mostly in pure TypeScript, although some of the cryptography dependencies are transpiled from Rust. So as Chris Patton would have explained had he gone before me, the DAP protocol is defined in terms of VDAF, which is verifiable distributed aggregation functions. So that's being standardized through the CFRG. And draft 02 of that just dropped a few weeks ago now. So we have an implementation of VDAF draft 01 in libprio rs, which is up on GitHub and also published as crateprio on crates.io. The significant thing that's missing from libprio in order to be an implementation of VDAF 02 is an efficient, which is to say scalable implementation of Poplar 1, which we don't currently have, but we're hoping to get to in the coming months. So as I mentioned before, Daphne and Janus are independent implementations of DAP, but they both use libprio to implement VDAFs. So certainly it would be nice to see more implementations, and especially ones in some languages besides Rust. If anyone out there is interesting. So yeah, all this stuff is up on GitHub. Please, go check it out. Maybe deploy them. Let us know how it works out for you. So we have been doing some measure of manual testing of interoperability between Daphne and Janus, which has gone all right. And going forward, we're looking at designing an interoperability test framework inspired by the Quick Interop Runner. The aim of which is, in a nutshell, you could take a DAP implementation, stick it inside a Docker container, and then besides the endpoints specified by the protocol, you would have a handful of extra sort of control endpoints that allow the automated setup and execution of interoperability tests. So the idea being that hopefully at some point we'll have some test running in like a continuous integration setup somewhere that gives us like ongoing results about whether the implementations are working and can talk to each other. Okay, so that's it for implementation status. And let's look at some interesting stuff that's changed. First up, there's coarse-grained report timestamps. So in DAP, a report gets uniquely identified by its nonce. And a nonce consists of the time at which the measurement was taken, and then a random component that's intended to make the nonces unique. So nonces have to be unique because they are used for anti-replay by the aggregators, and they are timestamped so that the aggregators can decide whether a given report falls into a particular batch interval. So Up until draft 01, the nonce was the number of seconds since the Unix epoch, and then 8 random bytes. As it turns out, that timestamp is high enough resolution to leak some meaningful information about the client. So as of the most recent draft, we now expect clients to round the timestamp down to the minimum batch duration, which is one of the long-lived task parameters. And we widen the random component to 16 bytes. So this allows a task to tune how identifying a timestamp is, because bigger min batch duration takes entropy out of the timestamp, but we can still ensure that nonces are unique and meet the requirements. So you can take a look at the linked issue in PR, the ones linked on the slide, and the chairs want to thank Shan Wang for championing this great idea. Moving on, okay, next big idea is aggregation jobs. So first, let's recall what the aggregation sub protocol is about. And I suppose here I should take a brief parenthesis to note that DAP consists of 3 sub protocols: upload, where clients are transmitting reports to the aggregators; then aggregate, where the aggregators jointly prepare inputs and aggregate them; and finally collect, where the aggregate shares are transmitted to the collector so that it can get the eventual aggregate result. Chris Patton is going to get into this a little bit more in just a few more minutes. Okay, turning back to the aggregation sub protocol, let's just unpack a bit more what it actually does. So at some point, aggregators are going to be holding some large number of input shares that have been uploaded by clients. And I mean, they want to aggregate them together. But in the taxonomy of DAP, you can't actually aggregate input shares. You first have to obtain an output share that is, from each input share. And that process of going from input to output share is what VDAF refers to as preparation. So preparation is generally going to require multiple rounds of interaction between the aggregators. Exactly how many depends on the VDAF in use. And that process is stateful. So what actually happens when we prepare an input into an output depends on the VDAF once again. So in the Prio family of VDAFs, we are only evaluating the zero knowledge proofs of the input's validity, and no actual transformation occurs from input to output. So it'd be tempting then to call this process verification or proof evaluation. But we know that in VDAFs like Poplar 1 or other VDAFs that have yet to be specified, there will be some meaningful transformation such that the input and output don't have the same type. Hence, we end up with the somewhat unhelpfully generic term of preparation. But one thing that we do expect is going to hold across all or most VDAFs is that preparation is embarrassingly parallel, since verifying the proof of one input's validity should generally be completely independent from another. So we want to enable the leader to be able to schedule the preparation of lots and lots of inputs in parallel for efficiency. And this is why we introduced this notion of the aggregation job into the protocol. Okay, so as we discussed, at some point the leader is going to want to schedule the preparation of a big set of shares. In the Prio family VDAFs, preparation can begin as soon as the aggregators receive inputs from the clients because there isn't an aggregation parameter in those VDAFs. So maybe in that setting, the leader, every time it receives 1,000 inputs, it'll dispatch an aggregation job, right? But in something like Poplar 1, you can't do preparation until you get an aggregation parameter from the collector. So there, maybe the collector will have gathered 10 million client inputs by the time it gets the aggregation parameter. And at that point, it's going to want to schedule, say, 1,000 parallel aggregation jobs to get the collector the aggregate results, aggregate shares as quickly as possible. So either way, what the leader will do is generate random aggregation job IDs and assign a set of reports to each job. That mapping of one job ID to many shares gets transmitted to the helper in the aggregate initialize request, illustrated here on the slide. And that job ID is going to be referenced in subsequent messages in the aggregate protocol. Right, so then the helper can use the job ID to index into its own storage to fetch the state and execute the next step of VDAF preparation. So this enables many helpers to work in parallel, provided they can share some storage, like a database or a key value store or what have you. And the other virtue of the scheme is that since the job IDs aren't secret, the job IDs aren't secret, and neither do they need any complicated anti-replay protections, because all the sensitive state is in either aggregator's trusted data store. So again, you can check out the linked issue and pull request on the slide if you want to learn more about the context behind this change. All right, moving on. Now let's discuss how the aggregators authenticate to each other in this aggregate subprotocol that we've just been discussing. So in DAP, aggregation is coordinated by the leader aggregator. Though actually in the aggregate subprotocol, the leader is acting as a client to the helper's HTTP server. Now, this channel between the two aggregators has to be mutually authenticated to prevent network attackers from impersonating either aggregator. We might assume that they talk over TLS, which helps to an extent with server authentication, but we also need client auth here. So what's in the spec now, as of the pull request linked in the slide, is a requirement that the leader has to set a bearer token under this DAP auth token header that we invented in the request it makes. And the value of that token is a secret pre-negotiated between the aggregators before the start of the protocol. Now, we did this because it enables the deployments that we have in mind right now, but this isn't really a workable solution for the protocol. So first off, long-term shared secrets between the participants is not desirable. We should do our best to avoid that, of course. And more to the point, because it's such a specific prescription, it makes it impossible for deployments to use any number of existing well-established auth-in or auth-z mechanisms widely used in HTTP APIs. So this in particular is something that we definitely want to change in a future draft. But at this point, we should take a step back from the specific interaction between the two aggregators and look more broadly at how protocol participants are authenticating to each other when they communicate in DAP. And we have such a summary in this slide here. So, right. So here we have the different communication interactions between DAP participants. So in the first row, we're looking at how the client interacts with the aggregators to upload its input shares. So in this case, the design requirements are confidentiality, which we achieve by having the client encrypt either input share to an HPK public key advertised by either aggregator. Of course, this is necessary because if a network observer could see the input shares in the clear, then that would defeat all the privacy goals of the protocol.
What do the colors mean, Tim?
The colors are intended to match up the requirement to the specified mechanism that satisfies the requirement. And then red highlights just like stuff that's going to change. Hence the motivation for discussing this with the working group today. Okay, where was I? Right, confidentiality. Right, so we protect the input shares in flight by HPK encrypting them to a public key advertised by either aggregator. Okay, then of course this has to be, we need server authentication in this setting because we want to make sure that the input shares are being transmitted to the authentic aggregators participating in a DAP deployment. So we do this by having the client fetch the HPK configuration that it's going to encrypt to over TLS so that the server identity can be verified that way. Excuse me, where was I? All right, finally, we have the DAP allows but does not require the client to authenticate to the aggregators. So it's tempting to require client auth as a mitigation for Sybil attacks. And in those deployments where this is possible, that's going to be extremely effective. But it's not going to be the case that every deployment will be able to have a meaningful client-side identity with which you could authenticate. So for that reason, we don't want to require it in all cases. Some deployments are going to have to allow unauthenticated input uploads, and we'll have to figure out some other means of mitigating Sybil attacks. We also, in my view, don't want to specify how a deployment would do client authentication if it chose to, which I'm going to come back to. All right, the next row is the communication between the leader and the helper during the aggregate sub protocol, which we just covered, so I don't want to spend a ton of time on it again. But yeah, confidentiality is generally achieved because they are communicating over TLS, and mutual authentication through that this current pre-negotiated bearer token scheme and the server's TLS certificate. And finally, we have the interaction between the collector and either aggregator to deliver aggregate shares at the end of the whole protocol during the collect sub protocol. So these aren't exactly the same because while the collector makes direct HTTP requests to the leader, it never actually talks directly to the helper. The communication between collector and helper is tunneled through the leader, which coordinates the collect and aggregate protocols. So we achieve confidentiality in both cases. Here I mean the transmission of aggregate shares from either aggregator to the collector by having the aggregate shares HBKE encrypted to a public key advertised by the collector. But we don't currently have a good story for how the collector is meant to authenticate to the leader. What's in the text right now is the same bearer token scheme as between the aggregators. And we currently have nothing to specify whether or how the collector and helper should authenticate to each other, which is necessary in the one direction because we don't want the leader to be able to present forged collect request parameters to the helper. And in the other direction, because we'd like the collector to have confidence that it's receiving an aggregate share from the authentic helper aggregator. Okay, so clearly we have a bunch of cases where what we do say about authentication needs to change, and others where we say nothing at all, and maybe we should. Oh, excuse me, before I move on, I forgot one interesting piece of red text in this slide, which is in the collector helper case, as it turns out, both of those actors already advertise an HBKE configuration and public key. So maybe that the problem of mutual authentication there could be solved by using HBKE's mutual authentication mode. Okay, where was I? Right, so clearly we have some inconsistent guidance and some missing recommendations about authentication in this protocol. So the question here broadly is, what should DAP say about request or response authentication? So to advance a straw man claim and stimulate some discussion, I'm going to claim that as much as possible, we should say nothing and stick to enumerating requirements for the security of the channels rather than solutions. DAP is built on top of HTTP, and one of the virtues of that is that we get to rely on existing mechanisms and implementations for all sorts of things like caching, error handling, or authentication. So in my view, we should be aiming for composability with existing authentication schemes widely deployed with HTTP APIs, with an eye towards sort of integrating nicely with the schemes already deployed by vendors who might want to operate DAP servers. So stuff like AWS request signatures, OAuth2, or even TLS client certs, which a lot of people do use for authentication. Now, of course, the exception there is the cases that I discussed where we mandate the use, where DAP mandates the use of HBKE. The distinction to keep in mind there is that we mandate that in those cases where we're tunneling a secure channel through some protocol participant. And so in those cases, we can't rely on an on a security property of an underlying transport. All right, so that brings me to some of the goals that the editors have for the next draft of DAP. Some, but not all. We're going to discuss other goals in a couple of the later presentations. So continuing from the topic of like good use of HTTP, we're thinking about rewriting the API mandated by DAP to be a little more resource oriented, if not full on RESTful. So for instance, instead of the upload endpoint being just /upload with all the meaningful parameters being encoded into the body of the request, you might have a path where you have like tasks and then encode a task identifier and then encode a report identifier, into the URI that you're uploading to. We're also interested in looking at the relevant best current practices documents and aligning with their guidance where it makes sense. For instance, to make use of better HTTP semantics and maybe doing something like extending the HBKE config endpoint into something like Acme's API directory. And as we were just discussing, we're interested in revisiting what the requirements are for authentication and what, if any, prescriptions we make. Okay, so that's it for me. We're looking forward to discussing all these topics in the working group here today and in the coming weeks and months on the mailing list and so on. Thanks.
Tim, can you go back or someone go back to a few slides to this authentication point? Thank you. No, but next. So knowing what I know now, which is not much, well, I know how this document works, but I mean more generally, this seems like a good approach, but I think perhaps what we should do is reach out to the HTTP API working group because they are specifying best practices for this. And I think they could, like, this is just like straight up an HTTP web app, right? Or HTTP web service. And so I think we should take their guidance on how we do this, which I think would quite likely be this, but I think we should take their guidance on that rather than reinventing the wheel. So I don't know who will be responsible for that. I suppose we could just do it privately. Actually, I'm not, but that would be my recommendation for this. As I say, I think these are like, I think that your intuition here that like people are going to have their own mechanisms and we don't want to interfere with those, like I think is like entirely correct. I think that's also true for the next thing you said about like the Acme, the directory and stuff like that. Those are also questions which like that working group might be able to help us with. So that'd be my recommendation.
Yeah, I agree, Eric. Thank you. I think we should also talk to some of the prominent operators of Acme I know a couple of them, to see what their experience has been with like this. Acme specifically mandates the use of JWTs and the directory. And like I know the people who run Let's Encrypt have opinions about those things. I'd love to hear from other Acme operators what their experience of that has been.
Chris Patton.
Yeah, I just wanted to mention I'm a little apprehensive about leaning on HPKE for mutual authentication. I kind of see the motivation though, because we have basically this collect request from the collector goes to the helper via the leader, and if the leader is attacking privacy, then this is a problem. We should also stipulate though that the collector is also part of the threat model, so privacy should hold as long as one aggregator is honest. That said, I think authentication would be useful. Ecker once suggested that like we change the protocol shape so that the collector communicates directly with the helper. That might help. So I just wanted to suggest that as a possible alternative.
Yes, I think that's a good point, Chris. And on the topic of direct communication, either aggregator, that's also something we've been batting around on the upload side of the protocol, right? Like at the moment, the way uploads work is that the client sends one message. Sorry, Chris, we can hear you. We can hear your typing. If you wouldn't mind muting, thank you. At the moment, clients will create one message that contains both input shares, transmit that to the leader, and the leader is responsible for relaying the helper's share to the helper. So this has some problems. Like the main problem with that, which I think we discussed at the last IETF, is that it means the leader may incur like significant costs for network egress. But it also forces us to deal with like this tunnel channel through the leader. So yeah, I think there's a few things that are still like that have the potential to change, right? About whether we introduce direct communication between protocol participants, which might significantly change how we approach these authentication questions.
Rich Sauls, in this case, HTTP API co-chair. It'd be great to come and ask for advice. We have done no work in this area, so it'll be like asking economics people. You'll get 10 people giving you 11 opinions.
Daniel Kahn-Gilmore. I want to reinforce the concerns, Tim, that you're raising about the dependence of this on proper behavior of some of the centralized players. In particular, the leader has worried me with this design. The goal here is to make it so that, as I think Chris said, the privacy should be preserved as long as there's one aggregator who's playing fair. And I worry that the leader has a tremendous amount of control here and could potentially de-anonymize or remove the privacy protections based on it being capable of just controlling which messages get routed where, both from the collector to the other helpers and from the reporter to the collector. So I would appreciate more thought about distributing the routing itself, message routing.
Yeah, I agree. So this is why I highlighted the problem of the collect request being authenticated all the way through to the helper. Otherwise, we do have a threat model in the back of the document that tries to enumerate like what exactly the leader can do that the helper can't. I think it's out of date though, and I think it needs some attention.
So, Scola, if we do have that problem, however, if the protocol is designed in such a way that the leader can independently breach the privacy of the protocol, then there's a protocol design failure because the collector, if you take the collector and the leader and you split them apart, the collector talks directly to the helper, and then the collector closes the leader, you're back in the soup. So the protocol must resist that, really has designed to resist that in either case. So I actually don't believe so while I'm open to having the collector talk directly to the helpers, I do not believe the rest of the problem the GKG is addressing. So one thing that, sorry, I'm finding some noise. There's a bunch of machine noise.
We have the secretariat on it.
Great, okay. With that said, I think I'm not averse to having the collector talk directly to like the helpers. In our implementation, we looked at what we like to send to both helpers independently, and that made us pretty sad. So I think if we do decide to do that, we have to have a mechanism that also allows you to have an ingest server, because like otherwise there are all kinds of problems where like we send like only one share, not the other, and you have to deal with that. So I think that's less of an issue for the helper, though it is like a lot of burden on the helper to like to make it have to on the collector to have to make the logic of like what if this guy doesn't answer, this guy doesn't answer. But it's obviously much more burden on a client.
Matt Finkel, Apple. So I also want to echo some of DKG's concerns, but separately, I noticed in the draft that you specifically say that only one only one helper is supported. Is that still the case? Because I did not pick up on any real blockers for that, but I'm curious what's preventing that. Thanks.
All right. So my understanding is that there is nothing in like the underlying crypto constructions, which is to say the VDAFs, that precludes additional helpers. Although Chris Patton is about to correct me because I think that's not popular. But in Prio, you can have arbitrarily many helpers. DAP kind of makes the soft assumption that there's exactly one helper, though. We're a little inconsistent, I think, throughout the draft about whether there's exactly one helper or not. But yeah, so in my view, there's a trade-off between, like, if you add more helpers, you get in some sense more privacy because more actors have to collude to defeat the privacy of the protocol. But that's a trade-off against like the resulting complexity of the protocol because you have so many more actors to coordinate. So I think where we're at the moment, I suppose when I say we, I just mean the editors of the document, is that exactly one helper is, yeah, I think that's just where we're at the moment.
Board over there, or the Reavers, if anyone's ever played that video game. Okay. So yeah, just to echo Tim's point, right now we don't support more than one helper. However, we intended to design the protocol in a way that we could go in that direction if that's what people wanted to do. One leader, one helper is kind of the simplest thing. It adds protocol complexity to add additional helpers, but I don't think that complexity is impossible to address. So if folks want to add support for more aggregators, I think we can do it. I wanted to go back to DKG's point. Collector to helper authentication doesn't have anything to do with the extra power that the leader has. The extra power that the leader has to do with Sybil attacks because the leader gets to pick the set of reports that are aggregated. We don't have a generic defense for Sybil attacks. That would probably be pretty hard, but something definitely we should find solutions for. I wanted to point out that the helper also can do Sybil attacks. By anyone who can upload reports to the leader can mount a Sybil attack. They have to collude with the collector because as Tim pointed out, the aggregate shares are encrypted under the collector's public key. So as long as one server's honest, the attacker doesn't see the result. But we want to be able to deal with the case where the collector is malicious. So because reports are unauthenticated, there's anyone can do a Sybil attack. And I think the leader's relative strength is kind of minor. And I would like to see defenses be more generic and not just apply to that particular situation.
Nick,
you're on the air.
I wanted to go back to the request authentication unless other people have an immediate reply to that. Okay. I would be concerned about not specifying or only specifying requirements, not specifying an effective way to do request authentication. Apologies, I didn't introduce myself. Nick Doty, Center for Democracy and Technology. My concern would be that that there would be like an extra unspecified or like silent spec for actually enabling interoperability between clients and servers, and we would like to make that easier. And so it would be good if we had a sort of recommended way to do that. Even if, yes, there are going to be cases where someone would deploy this with their own custom authentication scheme. Thanks.
Chris Wood?
On the topic of one helper versus multiple helper, I'm sorry to keep bouncing back and forth between different things. I wouldn't be surprised if we find out that Poplar in practice is just like too expensive to run, given how many rounds it requires for every single bit of input that you actually want to aggregate. So I don't know what that says about the fate of the DAP as a generic thing for all VDAPs versus DAP as a Prio specific or Prio Plus or whatever specific protocol. But I could see a future wherein DAP kind of gets less general, more specific to Prio, and maybe a heavy hitters like solution gets its own thing. Maybe that's Star, maybe that's something else. But if that were the case, then accommodating multiple helpers would be rather straightforward in DAP for Prio. But if it's like super general and we have Poplar with its constraint that it only works with one particular helper, it's not clear like what the result of in terms of complexity would be on the protocol. But I just wanted to note that like we're not set in stone here. We might see that things get less general or not as we go forward.
I think so on the topic of the leader's power and control over the system, can you just clarify, just so I know I'm understanding it? So the leader has the ability to reject shares, and therefore they are never processed by the helper, and therefore a colluding leader and collector can basically single out individual uploads. Is that correct?
Yeah, the leader get to select which shares get paired. Like as we saw earlier, right? It's good to assign or report shares to job IDs. However, the helper also can do this on a per share basis because the response that the helper delivers to a leader's aggregation request is going to include like a list of essentially a list of like per input preparation messages. So the helper could simply choose to like fail to prepare any individual input, right? So I'm not saying that that's good. My point is that in this respect, the leader, I don't think has a power that the helper doesn't. The other half-baked thought I have in response to that question is that I think ingestion servers, anonymizing ingestion servers, are probably a helpful mitigation here, right? And that one of the issues is that if you have in a deployment where clients are uploading directly to a leader, the leader gets to see all sorts of like interesting metadata about a report, client IP, stuff like that, on which basis it could choose to drop reports. So we anticipate that a lot of deployments are going to use some kind of intervening ingestion server. Hopefully you could just like stick an OHI server in front of the leader, such that the leader, I don't want to say it'd be impossible, but certainly it ought to be harder for it to be able to selectively drop reports.
I think that's the last word on this topic, and we're going to move to the next presentation.
Chris Patton?
Good morning, everybody. All right. So we had planned for me to go first. I was going to start with kind of an overview of, hold on, let me turn off this. There we go. We were going to start with an overview of the Dap protocol. I'm curious if people would find that useful at this point. Chairs, can you basically just tell me if I should do like a 4 to 5 minute overview of DAP?
Thumbs up. Thumbs waiver. 4 or 5 minutes, go. Yes.
All right. Cool. Well, so what this talk is going to be about is about how people use DAP. Recently, since adoption, a couple of use cases that have come up that we don't support very well. So what I want to ask the room about is what protocol changes should be made, if any, to accommodate these use cases. And as I'm talking, I think it would be helpful if folks would sort of think about how they intend to use DAP and whether the protocol really suits their needs. So as Tim mentioned, DAP centers around a particular class of multi-party computation schemes that we call VDAPs. These all have basically the same shape. We have a large number of clients, each with a measurement. Clients split their measurements into what we call input shares and upload these to a small number of aggregation servers. The aggregation servers interact with one another in order to verify and aggregate the reports. At the end of this process, each computes a share of the aggregate result. Then later on, a collector comes along and pulls aggregate shares from the aggregators and computes the final result. VDAPs are being worked on in the CFRG. There is a link to the document there if you would like to learn more. But this broadly covers things like Prio, Poplar, and other schemes that we found in the literature, and we hope this becomes a target for cryptographers to go design solutions for the problems that we have in this working group. So what DAP is basically is a way for executing a VDAP over HTTP. And as Tim mentioned, we sort of think of this as three protocols in one, all of which are being executed simultaneously. So the first is the upload protocol. Clients take their measurement, generate input shares, and then upload these to one of the aggregators, the leader, in a report. The input shares are encrypted under the public key of each of the aggregators in order to protect them. And at the same time, the aggregators are aggregating reports. So this process begins with the leader who gets all the reports. It picks some set and pulls out the encrypted input shares of the helper and sends these to the helper in an HTTP request. And then after some number of rounds, they have computed aggregate shares for the set of reports they were able to verify. And finally, we have eventually the collector comes along and grabs data. It does so by sending this thing called a collect request. And this is where in general, the leader's not prepared to respond to a collect request right away. In general, it has to interact with the helper first in order to compute the correct aggregate shares to return to the collector. So what it does immediately is it sends the leader sends to the collector this URI that the collector can pull later on in order to get the result. So that's kind of the shape of the thing that we're working on. The problem I want to talk about is this: how do we choose a set of reports to aggregate? And when you think about it, the most basic requirement for this is, well, the batch of reports needs to be sufficiently large that the set of measurements remain private. And what this means is kind of application dependent, but at least intuitively, the larger the batch, the more privacy that you get. But think about this from a sort of a usability perspective. What are the expectations of the collector who's grabbing data? This basic requirement doesn't say anything about like whether reports should have anything to do with one another. So how do we like kind of automate the process of grouping reports? So here's what we do today. Basically, reports are assigned to a time window, a discrete time window based on a timestamp that's generated by the client and included in the report. What a collect request specifies a batch interval, which determines a sequence of time windows. And what the collector expects is that the reports aggregated all fall into one of these time windows. Now we have certain restrictions on batch intervals. On the one hand, this is about like operational stuff. Like we want it to be possible for both aggregators to be able to efficiently pre-compute aggregate shares in advance of getting a collect request. And also there's privacy considerations here. Basically what we say today is that batch intervals must not overlap in order to avoid leaking small batches. And then Chris Wood is going to get into this problem a little bit more in the next talk. But the problem we're working on right here is there are a couple of use cases that this scheme doesn't support very well. So for starters, you might want to select a batch based on some client property. This was brought up in issue 183. Basically, reports, what the collector might want is that the reports are grouped by, say, user agent or location. So the collector would specify some predicate that defines a set of reports that go in the batch, basically the properties of reports that go in the batch. And you can imagine this could be quite simple, like give me the aggregate for all Chrome users or all Safari users, or a little bit more complicated, like give me the aggregate for all Chrome users in the US or all Firefox users that aren't in Canada or something like that. And yeah, so the problem though is that even a very simple version of this kind of grouping strategy is not well supported in the protocol. You can kind of hack around it, but we don't expect that any solution that we have today will scale very well. Now, issue 273 brought up even what's arguably a simpler use case. Maybe you actually don't care that reports have anything to do with each other. Maybe what you need basically is that reports are the batches are disjoint and that they all have the same size, or at least approximately the same size. And
Chris,
this is important. Yeah, go ahead.
Do you think it will help to have discussion on each of these piecemeal, or do you want to finish and?
I think it would be good to finish because I want to sort of talk about the generalization of this. But we can talk about these. I mean, I guess up to you.
Go ahead.
Okay. So fixed size batches are useful for a statistical analysis where you need to control the sample size. And for applications that want to compose DAP with differential privacy, this is also going to be important for tuning noise. And then there's also, waiting for the current time window to expire before you compute an aggregate can add latency to the system that might not actually be sort of necessary. So this sort of fixed size chunks use case, which was brought up in this issue, is not supported at all today because the collector has no control over the batch size beyond specifying the minimum size. Okay. So, all right. So where we are, we think, is that we need more flexibility. The question is how much. And we need to stipulate the fact that collectors in DAP are going to be more constrained than in a traditional database or telemetry system. And this has to do with some privacy issues, which Chris will talk about in the next presentation. Lots of open questions there. But even from like a functional perspective, we need to figure out what we need. One question is, what are all the query types? So I've talked about 3 here. Basically, this time series things that we have today, grouping by client properties, or partitioning things into fixed size chunks. What else do we need? Another question is, do we need to be able to compose different query types? This can get quite complicated, I imagine. Not all query types would necessarily compose. And finally, would every DAP deployment need to implement all query types, or is this something that we can allow folks to implement incrementally or not at all? So Yeah, so I guess I'll leave this slide up for the discussion. I can also go back and forth as needed. My proposal for draft 2 would be to take an incremental step that is minimal but is sufficient for our use cases. And I think this would involve enumerating all the possible query types that we want to support in a way that's extensible. And then I would add some additional requirements to this. Basically, the idea would be that the collector would include in its collect request a query that the leader would use to choose a batch of reports that satisfy that query. There are some additional requirements here to think about. Yeah, so my question, I guess, for the room is, does a protocol change that satisfies these requirements fit your use case? Do you think we need something else? And I see Ecker's in the queue in person. Yep. Go ahead.
I am, in fact, in person, not a Sybil. So
Do not believe.
I want to just talk this over before I start saying what I think we ought to do. So I guess I want to make two observations. One, I know Wood's going to talk about the privacy implications, but I think we're already like kind of out of the zone where we can plausibly make privacy assertion. So like the property that's nice about the current design is that you can just look at the possible, and queries is too strong a word, the possible outputs, and draw conclusions about the privacy properties of the system, right? You draw some k-anonymity conclusion, you draw some like conclusion about like intersection attacks, like you can just conclude it's safe or unsafe, but like you can just analyze it, right? And so I suspect that the minute we get to the point where, and the reason you get the property is because you guarantee only process each input submission once. And so as soon as you get out of that mode and you allow any other structure, which I think we're gonna likely have to, which I think is not quite clear to me what this allows, but if it does, and so like, all the sort of screwing around we've done is about trying to make that single processing requirement easier to implement on the helper and the leader, right? And so yeah. As soon as you get out of that mode and you say you can make one query, multiple queries on the same submission, which is not quite clear to me if this allows, but like it implicitly might allow. And certainly we're much harder to implement, if it doesn't allow. Then like the situation is much more complicated to analyze, and there's some other way to think about it. I'm not saying you can't analyze it, but I'm saying that trying to analyze what the protocol permits and doesn't permit will be almost impossible. You policy construction instead. To look at a different example, and so that's like the first thing I want to say. To look at a different example, the way IPA works, the Meta Mozilla proposal for interoperable private aggregation, instead of having the selection of the submissions is entirely within the remit of the effectively what's in this case the collector, namely that the collector collects all the submissions and then shoves them into the helpers for analysis, right? And so it can do anything it wants, modulo whatever mechanisms are provided for privacy. And so what I wonder is whether or not that kind of design, even if not that specific design, is what you want here. In particular, allowing essentially, instead of trying to create some language here that is sort of like restricted for what you can say, I wonder if we want something like much, much fancier instead, right? And so what I need a fancier is effectively to say, well, the collector can select any subset it wants via any mechanism it wants, and then they just get analyzed, and we have some other mechanism for ensuring privacy under those conditions. What that mechanism could be, I'm not quite sure, but as I say, once we have any kind of query mechanism that allows overlapping queries, we're already in the soup, and we're just going to have a flexibility question to analyze. So, like here's like my dumb version of this, which is effectively that the collector gets to upload a piece of JavaScript that the leader and helpers execute to determine whether to include a given section. Another version of that would be for the leader and helper to provide the collector with the entire inventory of every possible submission, and the collector simply say aggregate these ones, right? And so the reason I'm saying this is not to make the problem harder, but to make it easier, and to sort of admit the fact that we already are sort of like off the fairway, and try to solve the problem on the far end of the fairway instead of trying to solve the problem by restricted grammar here.
So one thing I'd point out though, So this fixed size chunk use case, here's kind of it's simple in that there's no reason to ever have overlapping batches. What we want is every chunk is disjoint.
Yes,
I
that
would
one's
love
easy.
to be able to support something like this that is simple and already kind of constrained. But I like your point though is well taken. Like whatever we do here, I think at a minimum we can try to prevent overlapping batches. Like that, I think that could always be defined. Although with like the grouping thing, like what this is kind of about is I want to explore the data. Like
overlapping batches, right?
Yeah. Well, they could be overlapping because the intersection between Chrome users and everybody else, that would be an overlapping batch, might tell you something about everybody else.
That's what I'm saying. That's what I'm saying. Yeah. So I think like so again, like I don't know. I guess what I'm saying is like instead of having like when we initially designed this, the kind of idea was we designed a grammar that would basically not let you say things that were illegal, right? And the grammar like wasn't even really a query grammar. It was just like this is how it works, right? And so and that grammar inherently enforced one query per batch, right? One query per submission. And so I think we need to go back and say what's the underlying rule that guarantees privacy, and then let's implement that rule on the helpers and not worry about like and not try to minimize state on the helpers and leaders, and just be like this helper leaders have to implement that rule, and then within the limits of that rule you can do any query pattern you want, and we won't try to restrict that. So I think that's probably a better way to go. And so like if we say right now the answer is one query per submission, then you like keep a counter on every submission and like and only allow one query, right? Yeah. And if the answer is some other rule, then it's some other rule. But I think like and then I think that what basically says like. And then I think the question is, what's the cheapest way to allow arbitrary queries, and not have to design a whole new language for that, rather than try to design a language for that. So I think that'd be my put on this. I think DKG is probably going to say like the answer would be to allow no queries, and the problem will be much simpler.
We're going to close the queue on this topic soon. So if you want to hop in.
Daniel Gilmore. I wanted to say something similar to what Ecker was saying, but maybe looking at it from a different perspective. The reason that people are comfortable participating in this scheme is because they want to give feedback that will help the person, the group that's developing their software, or they want to report some telemetry without risking their own privacy, right? And some of these types of disaggregation mechanisms require me as a user to report some specific things that I don't actually know how they're going to be used to differentiate me from the rest of the crowd. Yeah. And so if the goal is to convince people that they can do this safely, and not everyone's going to do the full analysis here, but they might read analysis from other people, then the more complicated you make this, the harder it is for somebody to analyze it and say, you cannot be disaggregated, right?
Yeah, totally.
And that seems to be defeating the purpose of all of this, right? If people are willing to just throw their hands in the air and say, well, we trust that the telemetry collector is not going to disaggregate me, then we don't need any of this protocol. So I would be very wary about the extent to which we are asking people to tag their submissions or opt into their submissions in some way that that has something complicated here. So Ecker's point of like, if we can say that the helper that obeys the right rules has this limit, which is like each query can only be put into one aggregate response, that's much easier to analyze and much easier to convince someone that they should participate than this kind of like, well, you might be disaggregatable if you happen to use a browser that more than 75% of other people don't use, or something. Like, how do I know that that's going to happen? Whereas the simpler thing is better. That's what I'm saying. Simpler is better.
Yeah, I totally agree with that. I think where we might be heading is I would like to be able to support at least use case number 3, but maybe we sort of so one like in the original design, one thing we were contending with is, what if you don't have enough data? So like, say your batch interval is T0 to T1, and you don't have enough data to actually get an aggregate to actually get over the minimum batch size. well, if I have enough data in T0 and T1, then that's good enough. Like, then that's good enough as long as I'm prevented from ever like doing an intersection over that larger interval. But I think, yeah, I think this is a problem that we can deal with. Simplicity is key here.
Sorry, let me just add one more thing. The fact that this is looking like it might be proposed as an in-protocol negotiation also makes me more worried, right? So if you could say, if you're doing PPM, you make a decision whether you're doing this kind of grouping or that kind of grouping, and the whole deployment makes a decision. So it's not in the wire format, right?
Yeah.
You know, as part of the configuration of your system, that you're going to be doing this type of grouping. That makes it easier for someone who's considering, do I want to deploy this? Do I want to participate as a helper? Do I want to report as a client? To know what they're getting themselves into, instead of being like, well, it could change up while we're going on. And it looks like here, this proposal for DAP2 looks like you've got it in the wire format, which suggests dynamic transformation of any particular collection over time. And that seems much harder to believe in.
Yeah, totally. I think that initially we would just say that the query type is configured out of band and is part of the task configuration. That's like, it's kind of punting, but I think that at least kind of addresses your concern.
Shen?
I also agree with the simplicity point. I think for that, the most important thing is we deliver a batch that satisfies some privacy guarantees. How the analyzing of the batch is totally up to the user, and it doesn't have to be part of the initial requirement for DAP, because like others have said, there are infinite possibilities of how a user wants to define these selecting groups or query groups. And also another point is these predicates you define for grouping the data, it can also be achieved by encoding your input shares or your measurement in a way that every client participating will subject to the same predicate. So everyone knows what kind of a task they are participating in, but later there's no way you can slice the data to pick up some users up. But you could like encode whether a user is using Chrome or Safari without actually picking out the group of users that are actually using Safari.
Chris Wood?
I agree.
A couple things. So I think Chris, you already mentioned this, or someone mentioned it, but the current restrictions that we have in the draft right now for validating or verifying batch predicate basically does enforce this limit that Ecker suggested, wherein you have basically one query submitting to a given report. There's no intersection allowed, and that allows us to like very reasonably conclude like certain privacy properties about the resulting scheme if you're using DAP in a specific way. It is perhaps overly rigid, particularly because it doesn't enable like the chunk-based variant here. So I would be in support of a perhaps looser enforcement that did enable that use case. But I guess what I'm concerned about is whether or not those two different, or rather, the enforcements that we put in place, whether or not it would yield a protocol or a system that's like useful in practice. There's certainly like a large gap that exists between DAP with like all these sort of query constraints and like other general purpose data collection systems that are used today. That's like DAP is not a drop-in replacement for these things. And if it's not a drop-in replacement for these things, like what is the incentive for people to use this protocol? The drill down use case that was mentioned, I think Ecker originally brought it up a while back, is particularly interesting to consider. And I don't know if that's something that people will want to have in order to like use DAP to enable privacy preserving collection. So I'm kind of conflicted here. I very much support guardrails where appropriate and where reasonable, such that we can reason about the resulting privacy, but I'm worried about the inflexibility that yields for the resulting system. And I don't know how to square that right now.
Yeah, I mean, I maybe there's a way. I mean, if anyone is insisting on supporting this, it doesn't sound like anybody is. I'll just say that I want to be able to use this use case. I think it's going to be really important in particular for differential privacy, which is something we haven't totally worked out, but I would like to at least take a step in draft 2 that deals with this use case. Go ahead, Wes.
Oh, thanks. So I always hesitate speaking about a protocol that I haven't read the draft, but that's never stopped me before. But I'm going to speak at a really high level. I mean, to rephrase, I think some of the things that other people have said that are extremely important is it's not even so much the complexity, but the instant you add 2 parties into determining whether you're getting the proper privacy aspects, or not, it greatly changes things, right? So I think about this protocol being deployed in a wide range of circumstances, everything from, in my house collecting data about my wife, and then, we have this mutual agreement, that's all fine. And these extension mechanisms would be great. To the flip side of, industry that have agreed legally on a binding, contract, and therefore only one side can pick it, and it's got to be static hard-coded configuration. So if you do end up putting this in a document, I greatly suggest putting in some guidance on when it shouldn't be used, like when, what the error message should be if I refuse to actually, resolve this conflict in this negotiation. I just don't do negotiation. It's hard-coded, and, there's legal auditing and representation behind it.
Thanks for that perspective.
Ecker, go ahead. We'll let you in, since you're insisting.
Well, I insisted, but
Rich made room for you.
But the drill down case is important. The one where you're like able to drill down based on client demographics is like I can tell you it is all the time. And yes, you get to the point where you're like, hey, the failure, like some statistic is like bizarrely high on, overall, and now you want to know where it is. Like that's like absolutely important. And it's not just a matter of time windows. With that said, I think it'd be okay to like roll out, certainly be okay in this version of the draft and the next version of the draft to only cover a small set of use cases. And it might even be okay if we had an extensible system that allowed for drill down later. But at the end of the day, this is going to be necessary for a lot of production cases. So,
thanks, Ecker. Yeah, I mean, it would be great. Given the known unknowns, I think we should try to take as small of a step as possible. I think differential privacy is something that we need to figure out the story of pretty soon. I would say it's higher priority than other things, but I mean, what would you say is higher priority? Figuring out differential privacy or drilling down at this point? Do you have a preference?
Aren't those the same? Aren't those connected?
They're connected.
I guess what I'm saying is, I think if you just did 273 for the next 6 months, that'd be fine. So you were asking something? Sure. Yeah. No. Let me give you a concrete example. We take measurements regularly of the fraction of TLS deployments, of the fraction of connections that are TLS. And so we have a graph you can see that's how many connections are HTTPS versus HTTP, and that was up into the right until about 9 months ago, and then for some reason it started going down for the world as a whole. And so we're like, what the hell? And so I asked somebody to go and look, and they were like, let's bucket it by country. And they discovered that there was 2 countries where it was that had bizarrely high numbers of reports and where it was going down. And if you remove those, it's backing up to the right. So that's a great case of drill down. We'd do demographic drill down to figure out what's going on in a statistic. And so it's not, you can't do it temporally. You got to do it by demographics. And so now again we have to do all preserving privacy, which is the complicated part. But and that requires repeated sampling on the same data set to solve that problem. And I guess if we can't solve that problem, I guess we're have a less useful protocol than otherwise would. But it's a really important use case we do all the time.
Chris Patton, do you have the guidance you need on this?
I think so. I think the connection to differential privacy, whether differential privacy is going to be necessary or If it's sufficient or even necessary, I'm not sure about, but we can get into that. We're low on
Chris
time, so I
Wood,
think we should move on.
You are the next presenter.
Cool. I just wanted to summarize my takeaway for Chris, and I left it in the issue as well. I think like addressing 273 with equivalent constraints that are currently in the draft, one report per query is a good next step for the next version, and then we could sort out separately how we want to deal with drill down and the related differential privacy issue.
Perfect. I'm going to file an issue, and then I'll start working on a PR to discuss. Thank you, everybody.
Thank you, Chris.
Okay. So talked a lot about privacy in the previous presentation, specifically for the collect sub protocol and what that means for DAP. So attempt here is to sort of take a step back and try and reason about what the threat model is for DAP, make sure we have sort of agreement there, what are relevant attacks that we want to consider, what are possible to consider in the protocol itself is like first class thing, and what are attacks that we need to sort of punt to deployment specific mitigations. Just a reminder, we just saw this, but I'm gonna repeat it anyways. The collect sub protocol basically allows a collector to issue a batch predicate for a particular query and get an aggregate result as the output. The details of like what happens internally are not really that important beyond the stuff that was talked about in chat. Like the leader can choose which reports correspond to a particular batch that satisfy the batch predicate. And that relates to civil attacks and stuffing attacks and whatnot. But at the end of the day, the collector issues a query with some predicate and gets back an aggregate result. And the question is, what is the right way of validating that batch predicate? Right now, in the draft, we're extremely constrained in terms of what is permitted as a valid batch predicate. There's a number of conditions. I should have linked to the specific section. But the first and foremost, most obvious one is that the number of reports must be at least the min batch size, so you get the anonymity guarantees that you want from the particular instantiation of DAP. You have that a report has not been included in more than max batch lifetime. We need to change that particular variable name or that constant name or whatever, but hasn't been included in more reports than is allowed. And importantly, we to deal with intersection attacks, which Chris was sort of alluding to previously, we require that no batches can intersect. They either have to be exactly matching, so two collect requests, they have to have the same start and end time interval, or they must be completely disjoint. Otherwise, the aggregators are supposed to reject, or the leader is supposed to reject that particular request. But as noted, this is not really flexible. It doesn't allow sort of the other use cases that Chris was going through, in particular group-based, or maybe we need a better name for that, but whatever, or chunk-based collection. And the motivation for this restriction was primarily due out of abundance of safety. We wanted to make sure that it was not possible to interact with DAP in a way that could lead or compromise the privacy guarantees that you want from the protocol. And this seemed like the safest and simplest thing to do at the time. I think since this landed, we've had lots of discussions about what are reasonable ways to enforce it. The underlying fundamental requirement, Ecker just proposed a new one that we might move to in the next version. But the gist is that, we had this huge gap. We plugged the gap, but we plugged it with perhaps too big of a Band-Aid or too big of a patch. So it's probably worth to identifying towards. All right, I'll take a step back. So if we wanted to identify what was sort of the minimal enforcement needed to take place and the minimal patch that we needed to apply in order to allow DAP to be queried correctly, it's worth like taking a step back and looking at what DAP is doing under the hood. So Chris already mentioned this, but but Dap is a multi-party computation protocol. It computes some aggregate function F that is parameterized by a query in this particular case that's provided by the collector, and then a bunch of inputs, a bunch of client inputs, X1 all the way to XI, whatever. All these inputs get fed in, collector issues a query and gets an aggregate as output. And the privacy goal that we want is that the aggregate output does not leak anything more beyond the aggregate itself. So in particular, the person who views or is able to interactively and adaptively query the system and get aggregates doesn't learn anything about honest client inputs beyond the aggregate that is computed based on those honest client inputs. So as Chris said, sort of that means you want the min batch size to be high, higher the better for more privacy. It's an application specific parameter or a deployment specific parameter. But that this isn't sort of intuitively or fundamentally sort of the privacy definition for Dap. The threat model that we consider, as a reminder, for privacy, not for robustness, is that there's some fraction of clients that are assumed to be malicious and others that are assumed to be honest. So if every client was malicious, the system wouldn't really make sense. So you assume you have some number of honest clients that are contributing to the protocol, contributing to individual aggregates, and the number of malicious entities are bounded. All of but one of the aggregators are honest, or dishonest rather. So we assume that every single, there's at least one honest aggregator that is, implementing and abiding by the protocol as specified, and everything else is malicious. And we also assume that the collector is malicious from the purposes, or from the perspective of actually interacting with the system as it adaptively queries it. This is kind of interesting because, in practice, I guess I could see, scenarios where the collector is the one actually configuring the system, deciding whether or not to use Dap in the first place. So a malicious collector could just easily not use Dap or, configure the system with parameters that are pretty awful. But we're sort of assuming that, that was done in an honest way. Clients are actively, or were configured with good parameters, and we're configured with, or actually using Dap, and we want to protect against now a collector that wants to subvert this honest bootstrap or an honest configuration for the purposes of learning individual information about client inputs. And as noted at the bottom, the robustness threat model is different, which does assume that all aggregators are honest. Okay, so there are a number of attacks that we've already identified and that we have either text in the document to deal with or open issues to address. The first of which is a stuffing attack, your classic civil attack, wherein the attacker, which could be either a combination of leader, helper, or compromised clients, is injecting things into the system, into the aggregate, to basically skew the result and allow the attacker to learn information about an individual client inputs. So in this example, we have all but one of the clients contributing to a particular aggregate are malicious, and the honest collector is, or the honest client is submitting its honest value. It'd be very easy for someone looking at the aggregate to determine what this honest input was, which is obviously something we want to protect against in actual deployments of the system. It's also I'm calling like an oversampling attack in the differential privacy litter. It's like continual release up to exposure, or I don't know, maybe that's not the correct technical term, but basically the idea is like you have clients that are contributing honest inputs over and over and over again up to a point where they've revealed or contributed that input too many times, and have sort of it's been folded into an aggregate, and the intersection of the combination of those aggregates therefore reveals information about the honest client's input. So in the sketch here, I have like multiple runs of the aggregation function F. The honest client X1 is contributing the same value each time, but every other client is contributing a different value, maybe either honestly or maybe maliciously. So this is kind of related to the stuffing attack, but kind of different in that it depends on like how you're using Dap, and specifically what you're using Dap to measure as an aggregate. So this is, I think, important to consider. The other attack, which is referred to as an intersection attack, was also discussed as in the previous presentation, which is why we have the sort of very restricted query batch or the batch predicate enforcement right now. It's where the collector is adaptively querying the system with different query parameters, trying to like yield different aggregates that may have overlapping underlying batches, and then using the aggregate results to compute some aggregate that is based on less than min batch size client inputs, which is a violation of the privacy goal or definition that I sort of sketched out earlier. The current query enforcement mechanism does not prohibit or does not allow this because it ensures that every single query must be disjoint or exactly the same. But this is obviously, I think, something we want to protect against. Okay, so I don't know if this list is exhaustive. In fact, that's one of the questions of the group. Like, have we sufficiently identified, all the relevant problems for privacy relevant problems for DAP? But the question that we're asking ourselves now is, what are reasonable mitigations for these particular issues? So let's take the stuffing attack as an example. It might be reasonable to say that this is a very deployment specific problem that you could deal with if you had, for example, client authentication that ensured that every single client input was honest and not maliciously generated. You could address it with some application of differential privacy, local or central or otherwise. I think it kind of depends on the specific deployment, and I don't know to what extent DAP wants to mandate or require anything about dealing with this particular problem. And the same goes for oversampling as well, because that's very closely adjacent to the stuffing and Sybil attack. The intersection attack, however, we can deal with in the protocol. In fact, we do deal with in the protocol right now, but it's as 273 or issue 273 sort of talks about. It's not. It can be improved, and we aim to do that. Okay, so we kind of already talked about this, fortunately, in the previous presentation. So and we kind of have like a proposed solution for moving forward. But so this slide was meant to say, or try to ask the question: what is the fundamental requirement that we have for mitigating intersection attacks? And the informal goal is to basically not allow the privacy definition that we described earlier to be violated. So all aggregates are based on the minimum batch size. And the enforcement is to basically ensure that every single report contributes to some number of or exactly one query in this particular case, as we were describing. And the question that was raised previously was, what is a reasonable way for expressing queries such as this privacy goal is meant? But I think the conclusion that we reached was, maybe don't constrain ourselves with how we express queries, just enforce the fundamental invariant for query validation or batch predicate validation, and allow whatever sort of queries make sense in the time being. And separately, we can figure out what the drill down solution would be. Yeah, DKG, I assume now's a good time to take questions.
So I'm thinking about these underlying constraints, right, that Ecker proposed in the previous talk.
Yeah.
Sorry, there's also something on a few slides back that I just don't want to go into the record if it was miswritten. You might want to update the slides, or maybe it's right and I'm confused. One more back. That one. All but one of the aggregators is honest?
Yeah, I realized that was wrong as I was saying it out loud. So
okay.
There's a typo here.
Okay, yeah, please update the slides in whatever archive we have. I just want to make that should be at least one of the aggregators is honest, right?
Yes.
Okay.
Yeah.
Just wanted to put that on the record. Okay, we can go back. In the situation where everyone submits one report on their own, then the types of constraints that Ecker was describing sound pretty plausible to me. I mean, I don't have a clear analysis of it exactly. I don't know for sure, but if we say you can only use each report in one query, and each query needs a reasonable size batch, then I'm fairly confident about those protections. In the event that each client might report more than once over time, I am much less confident in that defense. In the event that the client's reports might themselves be aggregatable, then I don't know how to evaluate this. So
Yeah,
I mean, this is the same thing with a lot of differential privacy questions, right? Right. You know,
yes.
If everybody's doing it once, it's fine. But then once you think about it over time and you don't know what the aggregation possibilities are, it's a lot harder to evaluate.
Yeah, I was chatting with Martin Thompson about this earlier in the week in the concept of IPA. This is fundamentally related to the concept of like over release or continue release in that setting. It's not clear like what is the best way to deal with this in practice. Like, do you on the client collector side, do you bound the number of times a given client can contribute its input across different aggregations or different tasks? So I don't know the answer there or the best answer there, but I agree that the current query enforcement mechanism and even the one that was proposed is only helpful in the context of a single like aggregate or a single task rather. It does not consider like leakage that might occur across tasks that have as input the same client values. Yeah, Becker, go ahead.
Yeah. So just to that point first, I believe that actually doing anything about that, sorry, under the constraint that clients are continuously reporting, as opposed to the clients, report only a small number of times, I don't want any way to do anything about that that doesn't also require some sort of reasonably strong client identification. Like if you de-anonymize the clients, obviously there's no way to, for instance, say that you can't bucket up all the clients, all the clients that queries over a month, right? So I'm not sure. I don't have a fix, but that's my initial observation. The second is, the version the constraint the DKG just suggested, which is to say, one query per submission and and no submission may be and no batch size is more than n is like playing on easy mode, right? And I guess I don't actually know whether there's an algorithm that provides the variant you describe up there informally, given if you just give me the matrix of like which queries are in which batches, I actually don't know if there's an efficient algorithm to determine whether it conforms with this requirement.
Yeah.
So maybe you do know, but I don't know. Do you know?
No, I don't think we have one either. And this is something we were talking about with some folks in the Slack channel about, especially as you start adding like multiple dimensions to how you express certain queries, how you enforce this like, non-overlapping.
Well, I'm actually suggesting something different. I'm saying, for each query, give me the list of submissions involved in that query. Like in normal form rather than like, in enumerated form rather than generative form. And can you simply determine validity of this constraint, right? And if we had an algorithm, so I guess where I'm going with this, I think I sort of indicated earlier, right, is that I think the easiest way to do whatever we do is going to be to require the both servers to maintain an inventory of exactly which queries each client was involved in, and then to prescribe an algorithm that determines whether the n+1th query is a valid query based on the previous n queries. And it doesn't say anything about how the queries are expressed because the only thing that the servers are required to express is query membership, right? And so I think that then that if we had that, then we'd be able, for the case of this, to ask the simple math question of like, is there an algorithm for looking at the matrix and determining conformance, right? And I suspect there is, but I just I don't know because I'm not a math guy.
Yeah, I mean, I think the thinking that I have right now is that each aggregator would mark reports that contributed to batches as dirty or not, based on whether or not they were included in particular queries, and then we would express the enforcement criteria based on like that dirty bit for every single report. That seems like the simplest thing right now, but I agree. As written, I don't see an obvious algorithm, but the simpler one that I think you were describing does make sense. Chris?
We can find a solution. I think I would like to be able to minimize.
Can you
Go ahead.
Can you start over? Like you were cut off at the beginning.
Yeah. I also don't have a solution for this, but I suspect like we've been thinking about this on my team for a little while, and I think I'm a little more confident that we can find a solution. But yeah, so I don't think we should rule anything in or out at this point, but just work on the problem. I actually wanted to add something. For folks interested in working on differential privacy, we are definitely going to have to make accommodations in the DAP spec itself. But over in the CFRG, we think that we're going to need to say something in the VDAF document itself about how to compose differential privacy. So if anyone has expertise there and wants to contribute, we would love to have your help on the VDAF document. And that's all I got.
Okay, cool. Thank you. All right, so just to kind of wrap up, I wanted to circle back to the high-level questions that I was trying to identify and hopefully get some discussion around. First, I guess, is the threat model clear with the the edit that DKG pointed out and that we discovered during while presenting it? Second of which is, are there attacks that we're actively not considering, or just not considering, not actively, that we think we should address either as first-class sort of citizens in the protocol itself, or as a deployment-specific thing? And the third one, do folks agree with sort of just right now constraining ourselves to mitigating the intersection attack using the sort of proposal that has now been floated and DAP, and sort of punting on the other ones for the time being? My sense isn't based on being in the room, but seeing chatter and hearing people talk, is that yes, like let's deal with the intersection attacks, and let's like separately in parallel talk about how we might consider these stuffing attacks and over release of data across tasks or the oversampling attacks separately. Yeah,
I think that's the right answer. I think so. I think 1, yes. 2, I don't know of any, but I'm sure we'll find some. 3, yeah. So I think that right now what we should do is effectively what you said and what I said and what DKG said, which is like any minimum batch size and any submission can only be in one query. It can ever be only in one query. And then like maybe we can relax that requirement later, but like that would get you pretty far. And I think is compatible with like a very flexible set of, actually quite a flexible set of queries that will support drill up. And we'll get you pretty far. And then like, and then like once we have some experience running, like I think we're gonna, like, this is a complicated enough thing, it's a new enough thing that we're gonna need some experience either like pre-RFC or post-RFC. So I think this would get us far enough to make some real progress, and then we could like, and then and like the Coop and I were discussing earlier, right? We could have addressed that problem by like doing the aggregate on like for like day 1 and then drill down for day 2, and like that would have also solved the problem in a slightly clunky way. So I think this is already useful functionality, and as Patton was saying, like let's get something there.
Please try to keep remarks brief so we can get to the last presentation.
Tim?
Tim?
You're muted, Tim. Or you're not muted, but I can't hear you.
Sure, I clicked the button. Okay, sorry. We were talking just now about the notion of tracking how many queries a given report had been used in. So I think actually this notion does exist in the draft. There's this concept of batch lifetime in there, and that's intended to accommodate Poplar. Because in the Poplar setting, it's expected that the collector would make multiple iterative queries against an aggregate in order to like essentially it would be sending longer and longer string prefixes to eventually figure out like what the heavy hitter in a population is. So yeah, so one, like I think we already have this, and I'm pretty sure, having written the code, that the honest implementation already handles it. And we should keep in mind that like I'm pretty sure that in order to make Poplar useful, you have to allow multiple queries against the same set of reports.
Thanks, Tim. Nick?
Yeah, thanks, Tim.
Nick Doty, CDC. I think this is a great start on the privacy threat model. I don't think we should be confident that we've considered every privacy threat, and in particular, I wanted to raise something that I think has come up in the chat, or Sophia had mentioned in another presentation. There might be some privacy threats that are about groups rather than individuals. And I think that'd be particularly important with small groups, but if I don't learn that, yes, this particular person had this particular report, but I do learn that,
Nick, unfortunately, we're not able to get your audio very clearly. Maybe you can repeat your question in the chat, and we can invite Sean to come up and show his slides, so we can get started there.
Thank you, Chris.
Thank you, Chris.
Good day, everyone. So this last talk is about task enforcement and configuration. This is somewhat related to the stuffing attack Chris Wood was talking about. So this is a list of task parameters defined in the current Dap draft. So today we are focusing on the parameters that are particularly important to a task. So here we have parameters like the VDEF verified key, which is not necessarily related to a task, and it's also a shared secret between the leader and helpers. So what we are talking today doesn't necessarily apply to these kind of parameters, but it definitely applies to things like minimum batch size. So when we say task enforcement, what we mean is how do we make sure the parameters we configured for a particular task is used by the clients, and how does the clients know these parameters are enforced and actually used by the aggregators. And when we say task configuration, we mean the process of creating the task with such parameters. And today, this is handled auto-band. There's no detailed spec in Dap. Dap just assumes it's deployment specific. But there are some potential issues and privacy issues with this. So first of all, what if the leader that configures these parameters are dishonest? This is not necessarily just the leader. It could be the collector, or sometimes the leader and the collector could be the same organization. When the task is constructed, either the leader or the collector, they define a minimum batch size that is too small for the task, and then communicate that with the helper. It's impossible for the helper to know if this size is too small. And also it's impossible for the clients that participating in this task to know the privacy guarantee in this task is compromised. Now, this applies to other parameters, especially if you adopt the differential privacy. There could be parameters like the differential privacy epsilon and so on. These parameters can also be VDEF specific. And like I mentioned, how does Dap earn client's trust? So the client know the task the participant is indeed configured of the right parameters and is enforced on the server side. So what I think needs to be addressed in Dap on the protocol level is first the transparency. So the client or the user, they should know the privacy guarantees they are getting. They should know the parameters that defines the privacy guarantee of the task. Secondly, there needs to be some enforcement on the server side in the aggregators. They should make sure the parameters configured for the task is indeed used on all the clients that participating in this task. So what we mentioned in issue 271 is a proposal for Inband task enforcement. It has basically three things. First, we let client know about the task parameters being used. This will help better auditing, so the client can see what parameters they are participating in. They can also develop policies to either opt in a task or not, or have some way of auditing the tasks they have been joining and the parameters being used there. This can also allow client to have some of these parameters hard-coded on the client side. For example, if you are using differential privacy, the client could decide, I want to use the local differential privacy of a particular epsilon or lower. And the second thing is the client needs to send these task parameters back to the server. We want to use the extension in the current report because the extension is supposed to be extending what the report is providing. So this is a way to make it extensible for different VDAFs. We can have one particular extension data type for a VDAF with a particular DP guarantee or a particular privacy guarantee. And also because the extension is used in AAD, so a malicious aggregator cannot change these parameters later on. They will fail to decrypt the report. And thirdly, the aggregator should check the parameters coming from the extension match what they have stored for that task. In this way, a malicious client cannot pollute the aggregation by permuting the parameters in the extension. So as a quick example, here you have a leader that sends the task parameters to client and helper auto-band. Each client will seal the input shares with the extension that contains the task parameters and then send those back to the leader in the report. The leader will verify the parameters from the extension, and when the aggregation flow starts, it will send the same extension in the report share to the helper, which will do the same verification. Now, once we have this kind of in-band task parameter delivery, we can go one step further. This is what was proposed by issue 290. What this does is we can actually create the task on demand automatically when we receive a new combination of task ID and task parameters. So in this diagram, we no longer have the auto-band task parameter distribution between leader and helper. So the parameters are only given to the client. The client does exactly the same thing as in task enforcement. But when the leader receives the report, if it's an unseen task ID and task parameters tuple, the leader can create a new task on demand. Similarly, helper can do the same when it receives the same combination of task ID and the parameters. In this way, we avoid this auto-band task orchestration between leader and helper. And also, there is a nice side effect that any malicious client permuting the parameters will cause their reports to be aggregated in a different batch than the good reports from normal clients. Because in this way, essentially, a task is identified by not only the task ID, but also the group of parameters it was defined with. This also, from an implementation point of view, is easy to do with any frameworks that implement a group by operator. So you can essentially group by the report by their ID and the task parameters. In that case, your task object becomes kind of an index that just groups reports together. Now, in this last slide, this is a small optimization. Like I said, in this scheme, the task is identified by a tuple of task ID and the parameters. We can optimize that further by creating the task IDs, not randomly as a UUID, but as like a hash of some shared info among all the clients participating, and the extension that includes all the parameters. In this way, the ID can be sent to the server, and as one thing the server have to verify as a genuine task. But this does have some implications on whether the task ID can be defined on the server side before the task starts. So this is really just an optimization. That's it. At this point, I want to end the presentation and take some points.
Okay, Tim, you're on the air.
Tim, please.
There we go. Thanks. Thanks, John, for the presentation. So I just have one note on the notion of like dynamic task configuration. Based on our experience running the notification analytics. So yeah, and that's some the configuration describes in that like the task analog are configured dynamically just based on like what inputs are getting uploaded in that system's ingestion servers. Anyway, and it turns out that has been quite valuable because it has enabled like the mobile OS vendors to add new aggregations to the system without needing to explicitly coordinate with like the three organizations running the other servers. So yeah, I just wanted to put up that comment that it is kind of valuable to have this dynamic task configuration capability.
Agreed. Thank you. Chris Patton.
I also think this is a great idea. I'm not very clear on some of the security considerations. I would like to see those fleshed out a bit more before we consider a PR, like before we consider a change. But like, it would also be nice to like look at a PR for this. For me personally, like thinking through the security implications and like what we have to do on the to implement on the server side. So if you wanted to, I would say like if you wanted to start drafting a PR for people to look at, I think that would be a great start.
Yeah, we can start preparing a PR for this. Thank you.
Daniel. I appreciate that you're thinking about this because I think it pushes us to really think about how things are going to be deployed. When I think about how things are going to be deployed, I like to ask a couple of questions by taking the perspective of some of the participants. As a client, I don't know how we would expect the client to set to be able to choose the consent options here of like, well, I'm okay with this kind of parameters, but not that kind of parameters. That seems very complicated and difficult for clients to do, and I'm wary of asking clients to do that kind of configuration choice. When I think about asking someone to operate as a helper, the helper's job is to keep the system honest, as far as I can tell. And if my job is to keep the system honest, then I'm going to need to make some very specific decisions about what types of parameters I'm willing to accept, not just take, oh, here's a new set of parameters, I'll just adopt them. And that means the helper is going to need to actually make some constraints on their system about what requests they're going to accept. And now you're asking the helper to make some pretty sophisticated decisions as well. I think the way we want people to step up and say, yes, I'm willing to be a helper because I think this measurement is valuable and I also want to protect the client's privacy. It seems, I don't know how you're going to offer those kind of constraints if this dynamic configuration is happening.
Yeah, can I just quickly address the question? So I agree for clients to understand all the privacy parameters and decide to opt in or not is not realistic for most of the clients, but I think the transparency needs to be there. So for the few that do understand and do want to see what kind of a collection schema they are participating in, I think this is very valuable. And sometimes these kind of opt-in, opt-out policy could be defined by the organization that provides the client side to the individual clients. That's one thing. And then the other thing is for the, you mentioned for the helper, it has a responsibility to, know the parameters that they receive and make sense privacy-wise. That is true. And for any issues 271, we also said something about like if you have differential privacy guaranteeing, then we could implement some sanity check on the helper side, and this can be extended to the client side as well. That the privacy, differential privacy parameter you received indeed makes sense for the kind of batch size you are defining. But I think here the key is one, the transparency to the client. Today we simply don't have that on the Dap side, and two is like you said, when you deploy something, you have to worry about how do you communicate these parameters between lead and helper. You could find any secure ways to deliver these, but I would think it's better that you don't have to worry about that. There is one option for you to actually configure these using the same route that you upload the report to the aggregators. and you achieve both transparency and enforcement in one solution.
Thank you, Sean. That concludes our meeting of privacy preserving measurement. Thank you everyone for participating and for getting through our whole agenda.
I noticed continuing discussion, particularly about STAR in the Zulip room. Feel free to take that to the list. We haven't issued a call for adoption, but feel free to comment on that on the list, because I see that some people are interested in it. If there are topics that warrant an interim, feel free to come to the chairs. We could schedule such.